Hey everybody, it's Ms. Bell here from the Science Lab, and in my video today I'm going to be talking about natural disasters. Now in my last video that I made for you guys, I talked about severe weather, tornadoes and hurricanes. Now sometimes severe weather can be considered almost a natural disaster, because natural disaster, just broken down, means it's an occurrence that happens outdoors in nature, and disaster meaning there might be some really bad things that happen after the events. Maybe people get hurt, maybe animals are affected, like their habitats are destroyed, maybe there's lots and lots of damage to surrounding things, like businesses are destroyed, houses are destroyed, tall buildings are completely flattened, so on and so forth. So my 4 natural disasters that I'm going to be talking about today are, drum roll please, come on, drum roll. My natural disasters are going to be thunderstorms, drought, blizzards, and tsunamis. So here we go. So when you're talking about thunderstorms, there are some main ingredients that help create or produce thunderstorms. You're going to need moisture in the air. You're going to need unstable air, and you're going to need uplift, which is just movement going upward. And when a thunderstorm happens, it is produced from a type of cloud. Do you guys remember that cloud I mentioned when I was talking about tornadoes in my video last week? They go really high in the sky. They can be huge in size. They're big, puffy looking, but we would call those types of clouds cumulonimbus clouds. And the way that those types of clouds are created and formed, well, let's say here's my ground and there is some air above my ground. This air is going to be really hot and moist, meaning it's kind of filled with moisture. And I'm about to show you again what it looks like when hot things rise and cold things sink. So with my hot, moist air above my ground, it's going to start rising up in the sky and go high into our atmosphere. And when that happens, more air is going to start filling in its place. So my hot, moist air is going to rise, more air is going to come in that's hot and moist, and it's like this movement going higher and higher, and eventually when that air that is hot and moist gets up into the atmosphere far away from our planet, it's going to start cooling off and condensing. That's when we're going to start seeing the formation of those cumulonimbus clouds, which will bring a thunderstorm. And with thunderstorm, we're going to see gusty winds, we're going to see precipitation, maybe in rain or even hail form. We might hear thunder, we might see lightning, so lots of things are happening to create a thunderstorm, and lots of things are happening during a thunderstorm. So for my experiment that I'm about to do, I'm going to show convection currents. And the materials that I need are ice cubes that have been colored blue. I also am going to need a clear big tub filled with water. Now I'm going to let this tub of water sit out in a room for a few hours so that the water becomes what we call room temp. Not too cold, not too warm, not too cool, not too hot. Now when I begin my actual experiment, I'm going to drop my ice cubes on one side of the tub. And then on the opposite side of the tub, I'm going to drip red food coloring. So I have red that represents kind of a warm water, and then blue that kind of represents cool or cold water. And we're able to see this natural movement happening in the water. You don't want to shake the table, you don't want to move the tub. We want to see these kind of almost circular motions happening on their own. We're going to see one color sink down to the bottom, and we're going to see another color float up to the top. And this is what's happening when those thunderstorms are forming, when those cumulonimbus clouds are forming high up in our atmosphere. That warm air is rising, 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 higher and higher in the sky. Even though our experiment is with water, the same type of convection movement is happening, whether you're talking about water or gas, like in our sky. So as that warm, moist air rises into the sky, it's going to start condensing and forming clouds. And in this next experiment, I'm going to create a cloud in a soda bottle. But before I do, I just want to explain how this cloud is formed. So I'm going to be squeezing my bottle and unsqueezing it. When I squeeze my bottle, that represents kind of the higher temperatures and higher pressures down toward the ground. And as that warm air rises, that pressure is going to get lower, so low pressure and lower temperatures, because it's going to start cooling off the higher it gets. So when I squeeze it, high pressure. When I let go, low pressure. High pressure, low pressure. So let's get to it and let's form a cloud in a bottle. So the first thing I'm going to do is take my 2-liter soda bottle without the label and spray some water in it. The water inside my soda bottle is going to represent some of the moisture in our air. And I'm going to screw the lid on tight and then give it a good shake. By shaking the water in the bottle for about 10 seconds or so, this is adding energy inside my bottle. And this will allow some of that water to evaporate more from the liquid phase into a gas. So after shaking, there's going to be more water vapor in the atmosphere. After that, I'm going to light a match, and I have to do this very quickly, but I'm going to unscrew my soda bottle, blow out my candle, and then put that match with the smoke coming out of the match inside my bottle. And the smoke in my bottle is going to represent things that we might find in our air or our atmosphere, such as pollution or certain debris or dust. And now I'm going to play around with squeezing and unsqueezing my bottle. Remember, when I squeeze my bottle, we are able to not see a cloud. This represents some really happy, nice weather. But when I let go of my bottle, this represents really cloudy and kind of like thundery weather, so to say. So I also am going to play around with a flashlight to let you see a little bit more of what this cloud might look like. So this bottle just in itself kind of represents that warm, moist air that rises high in our atmosphere. And as it rises, that pressure decreases and the temperature starts dropping and getting cooler. And the water vapor also condenses on the pollution or dust particles that we might see in our atmosphere. And these types of droplets that are condensation, they are forming clouds in the sky, and this is all the beginning of a thunderstorm.
So what I'm going to do now is I'm going to make rain. And by doing so, I'm going to be working kind of with heating and cooling, and kind of like with the water cycle, condensation, evaporation. So for this little experiment, I'm going to need a metal pie pan filled with some ice, and I'm going to hold that over some water that's being heated up almost to a boiling point, and it's going to create steam or water vapor in the sky. Now, because I'm working with hot things, I'm going to wear protective goggles over my eyes and gloves over my hands. So here we go.
So to begin this experiment, I'm going to plop my frozen water, in this case it's ice cubes, in my metal pie pan. Then I'm going to put on safety equipment, goggles over my eyes and gloves over my hand, because I'm working with some really hot stuff. If you do this experiment at home, you do need a grown-up to help you with this one. So, as you can see, I have a glass beaker and it's filled with water. My beaker is sitting on top of a hot plate which is plugged in and providing heat to my water. This is going to bring my water to a boiling stage to heat up my water. I'm then going to hold my cold pie pan over my beaker. Now the cold pie pan kind of represents the atmosphere high in the sky, where the temperature is dropping. It's pretty cold up there. And my steam that is being created from the boiling water, that hot water vapor is rising up and coming in contact with my cold pie pan. Now my steam is going to condense when it hits this cold surface. And this is the same thing that kind of happens in our water cycle. So the water gets heated from the sun and starts to evaporate into water vapor, and from the Earth's surface it goes high up, and then it starts to condense high up in our atmosphere when it reaches those cold temperatures high in the sky. Now with this experiment, we are going to see condensation happening on the bottom of my pie pan. So my hot steam is going to start cooling off as it hits the pan, and it's going to start collecting. And when these condensed water droplets start growing larger and getting heavier, they aren't going to be able to sit on the bottom of my pan anymore. They are going to start falling, and in the real world we call this rain. So with this experiment, you can create your own rain by using not a lot of materials. And since we're talking about thunderstorms, that's why I wanted to create a cloud, and I wanted to create the rain like you see right now. So the second type of natural disaster I want to talk about is a drought. Now you might not know what a drought is, and before I go into explaining what a drought is, I want us to take a look at some pictures. I want us to make some observations with what we see in these pictures to maybe try to figure out what a drought might be before I explain it. Here we go. So when you look at these pictures, what do you notice? Where do you think these pictures are taking place at? What are some colors that you observe? Do you see animals, or are animals nowhere to be found? Also, do you see plants, or are there no plants? If there are plants, are the plants healthy looking and full and bright in color? Or if they are there, do they maybe seem unhealthy, like they're dried up and not green or full of color? Is the sun there? Do you think in these types of environments it might be really hot, or do you think it might be kind of cold? So these are some things to take into consideration when you're talking about drought. Alrighty, so when you're talking about a drought, that is just a very long period of time where you go without any form of precipitation in a particular location. Remember, precipitation could be snow or rainfall. Now, during a drought, there's going to be a lot of heat coming from the sun. We're going to get a huge amount of heat energy. And with that combination of a lot of heat and not a lot of rain, there are some bad things that can happen to an environment and the living things that live in that location. So, one big thing is during a drought, there are not going to be a right amount of plant life having the ability to continue growing, because one of the basic needs for plants is water. So without water, they can't thrive and survive and grow healthy. Also, without having the proper amount of rainfall, is we don't have the amount of drinkable water, like fresh water, that humans and animals need to survive. So without being able to grow crops, maybe like carrots, tomatoes, lettuce, fruits and vegetables, that means that us as humans and even the animals in our environments, we're not going to have the proper food and nourishment that we need to stay alive. Also, with a lack of water, there might be certain bans put on us as humans with some of our everyday activities. We might not be able to wash cars. We might not be able to water our lawns or our flowers because we are trying to conserve whatever type of water that we have to be able to drink it or even grow crops. Now with drought, it's going to dry up our land, dry up our soil on the top layer of our ground, and we might get all of that soil and dust being blown all over the place like big dust storms. Also, because of the lack of moisture and water on the lands, that might create really dry trees and shrubbery, and because of that, wildfires might be more prone during a drought because there's no moisture to keep those flames away. And drought, like I mentioned, is an extended period of time. That could be months without water or even years without water. And every location has different climates, but droughts are not just water not coming from the sky maybe every 2 or 3 days. It has to be a long period of time. So for my third natural disaster that I'm going to talk about, I want to give you some clues, and I want you to make a prediction and try to guess what I might be talking about. So here are my clues. I'm going to say white, windy, freezing cold, pretty dangerous, and extreme. Can you guys do that with me? Extreme. There we go. Now, if your guess was a blizzard, then ding, 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 you are correct. And when we talk about blizzards, that is just an extreme snowstorm that has to have 3 conditions in order for it to be classified as a snowstorm. One of those conditions is how long this snowstorm lasts. It has to be 3 hours or longer. Woo, that's a long time. A second condition is wind and how fast those winds are blowing. For a blizzard, it has to be 35 miles per hour or faster. And the third condition has to do with visibility. When we talk about visibility, that is just how we are able to see around us. Can we see really, really far and really, really well? Can we only see a little bit of the way and then we can't see anything past it? Can we see barely anything in front of us? Or when we open our eyes, we don't see anything at all, anything that would be normal. And with a blizzard, it has what we call low visibility, meaning if I step outside in a blizzard snowstorm, I'm only going to be able to see so far in front of me, and then everything behind that and far to the extreme, I just can't see because I'm blinded by all of the snow. So with a blizzard, we get those winds blowing all of that snow all over the ground and around us. A blizzard doesn't necessarily mean a lot of snow, but for a lot of blizzards, you will get a good amount of snow blowing and then settling and then piling up. As you can see from my illustration right here, we can barely see my car, we can barely see my tree, we can barely see the electricity poles because of how much snow is being built up and settled. So I wanted to show you guys a visual in regards to blizzards. So when talking about visibility, I am going to take some clear plastic. I'm going to splatter some white paint on it, and this white paint is going to represent snow. I'm then going to grab a clear box that I'm going to cut styrofoam pieces in it to represent snow kind of on the ground and kind of piling up. I'm then going to place some sort of creature inside my box. It could be a Lego person, it could be a bug, just anything for us to have a visual. And then I'm going to layer these plastic sheets over the front of my clear box, and this is going to represent the snow blowing harder and harder and harder, and us not being able to see my creature. As I move my plastic to the side to see what we first saw, you can see how our sight is no longer anymore. Our visibility is low. We cannot see our creature even though we can see our styrofoam snow. My fourth and final natural disaster that I'm going to talk about are tsunamis. Now, tsunamis scare me. Miss Bell is scared of tsunamis. I've never been in one, I've never seen one, I've never witnessed one, but from what I know about these powerful natural disasters, well, they terrify me. Basically, a tsunami is a big, huge wave coming from water to the land. And when it comes in contact with the land, it can be disastrous. It can cause major damage to anything that's on that coastline, such as houses, businesses, any sort of farms, and of course people and animals and plants are in danger as well. Now, the way a tsunami is started can be caused by many things, not just one thing. So one example would be an earthquake happening underneath water, on the ground, underneath like an ocean. Let's say an earthquake happens, it builds up a lot of pressure and a lot of energy, and then bam! All of that energy has to go somewhere, and it is dispersed through the ocean. And all of that energy then flows away from that earthquake, causing those big, big waves traveling through the water and eventually hitting land. Another cause of a tsunami is a landslide, maybe on a hill or a mountainside. That might be soil or rocks or boulders that somehow slide down the hill or down the mountain, and they might splash into a lake or an ocean, which then cause ripples. Another example might be a volcano erupting, because we know when volcanoes erupt, they usually cause earthquakes and usually cause landslides. Another way tsunamis could be started are from anything from space coming into contact with our planet's surface. Let's say an asteroid is flying through space, it comes through our atmosphere and makes contact with our planet. Bam! That big, big meteorite is going to cause a lot of energy and being dispersed if it comes in contact in water. Another way that a tsunami could be started is, let's say you're at a glacier, which is a huge, huge chunk of ice, and at the very end, a big chunk of that ice gets broken off and falls into the water. We would call that an iceberg. Well, that ice hitting the water is going to have an effect. That energy is going to kind of fly away from the ice and cause ripples within the water. Now, there are signs to look for with tsunamis. One thing is nature. Listen and watch what animals are doing. Let's say everything is calm and peaceful, and then all of a sudden you hear birds and they're flying away from the ocean. Animals have a natural instinct to know something major is about to happen, even if they don't know exactly what it is, but pay attention to those signs. Another caution to look for is if you're at the coastline or the beach shore and you see the water receding, moving away, and you see a lot of exposed sand in the bottom of like an ocean, that is a huge, huge sign to get away quickly. So here's a video I found online that gives us a visual of what a tsunami looks like. So to start off, there was an earthquake under the water. Two plate tectonics collided with each other and created an earthquake, and that created a bunch of energy that is being dispersed throughout the water. In this case, it's an ocean. This ocean water is collecting to itself and rippling out these effects. You see right here, this is where the ocean is pulling back from the shoreline. That's a huge, huge sign of a tsunami is coming soon, and that you need to go to safety right now. Now, if you are on the shore looking out to the ocean, these waves might look really, really small far away. But as they get closer and closer, you will see how massive they are, because as they get closer to land, their power increases and the wave height gets higher and higher and higher as it comes crashing into the shoreline. Remember, these tsunamis are rare, but when they do happen, they are unexpected and very destructive. So that's all I've got with my 4 natural disasters with this video. Remember, they were thunderstorms, drought, blizzards, and tsunamis. And sometimes natural disasters coincide with severe weather, like thunderstorms or tornadoes or drought or hurricanes or blizzards. Thanks so much, guys. I will see y'all next time. Bye.